Hey there, Joel here, and welcome to this online class. Today we are going to start with a new chapter from class 9th Science. And I think this is the first time I'm going to give out the name to you, and that is Force and Laws of Motion. But before that, let's roll this intro. Alright, in class 8, I'm sure you have studied a chapter which was Force and Pressure. And in that chapter, you learned a couple of things with regards to force. Now, if you have forgotten about it, then I'll just give you a brief recap of what you had learned about force. So, take a look over here. I can say that there's a conveyor and there's one ball hanging, and we'll drop that ball in one machine and we'll apply force to it. Okay, so after I apply force, this is what you will get, right? So I can say that force can change the shape of an object. So when I apply force to any object, I'm certain and I'm capable that to change a shape of that object. Now, why am I discussing about all whatever you have studied in the past is because the certain ideas and understanding of what you have studied will be used in this chapter, Force and Laws of Motion, to come to a different understanding, a different level of understanding. So please remember each and every point very clearly and try to imagine it and understand it, because that's how you will be able to gain knowledge, especially in chapters like this. So first thing, don't by heart it, but just understand that when I apply force to any object, I can change its shape. Another example would be taking a piece of paper. Piece of paper is an object. I apply force and crumple it. I have changed from a nice sheet of paper into crumpled ball of paper. Okay, so force can change the shape of an object. Let us go to the next one. Okay, so here one ball is being dropped, and what I do is I apply force. So the moment I apply force, I'm changing its direction. So the ball was falling down straight down on the ground, and I apply force in such a way that I change its direction. So force can change the direction of an object. Okay, so another example would be maybe when you are playing football, someone passes the ball to you and you kick it to someone else, or it hits the goal post, and it moves in a different direction. So force can change the direction of an object. Let us take another example. So there is a ball and some force hits it, it is moving slowly, and the moment there is another object which is hitting it, it moves with a greater speed. So I can say that force can change the speed of an object. So we have learned till now, force can change the shape, force can change the direction, and force can change the speed of an object. Does it always have to be that force will change the speed and increase the speed? No, sometimes it can decrease the speed also. So the main understanding is force can change the speed of an object. It might be fast or it might be slow. Okay, next thing that you have studied in a class 8 is that 6 people are pulling a rope, and you can say like the game of tug of war, and both the sides, both the teams, A and B, the blue and the red, are pulling the rope with equal amount of force that they have. Okay, the full energy is put over there to pull the rope, and the rope doesn't move at all. You can probably have a, so let me mark this place. Okay, so you can have a kind of a small marking over here, a kerchief tied over there, a ribbon, and it's not moving nor left nor right, which means I can say if forces applied equal, okay, if the forces that are applied on both the sides are equal, then we say that it is a balanced force. What do we mean by it? Balanced force is nothing but force on either side that is applied is equal. 10 newtons on this side, 10 newtons on this side, both the side it is equal, right? Someone is pulling with the force of 10 newtons on one, someone is pulling with the force of 10 newtons on the other side. Now when forces are equal, we say they are balanced forces. I hope you are clear with this part. We can say, okay, someone is really strong over there and someone puts really extra energy and force and is they are able to pull the other three teammates on the other side. Now here the force that is applied in one side is more, then the other side is less. So here we can say that if forces applied are unequal, then we say they are unbalanced force. Okay. Uh, okay. Just a quick note for you that I've just got bad cold, and that's probably you might hear my sound a little bit off, not so good today. Please bear with me, okay? That's it. So we have balanced force and we have unbalanced force. Balanced force is when the forces are equal on either side, and unbalanced is when forces are unequal on either side. Also note that three people are pulling that rope in one direction, right? So forces add up. So forces in the same direction you can add. Someone in total it might have been 10 newtons, but someone might have put a little extra. Who is stronger might be putting a force of 5 newtons. Someone who is weak might be pulling with a force of 2 newtons. This is just an example, okay? So total will become 7. Someone might be pulling it with 3 newtons. So total becomes 10. So 2 plus 5 plus 3. Total is 10. Alright. So forces in the same direction you can add. Forces in the opposite direction you can minus. So that is how you will get, if someone, in the second case, the rope was being pulled, right? So which means the force on the other side was not so balanced, it was not equal. So that's the reason you could pull it with a net force on one side, which is more. They were able to pull all the teammates on the other side. So balanced force, unbalanced force. Alright, so let us move and study something which you need to know in class 9th. Okay, there was a scientist by name Galileo, and he said, okay, objects move with a constant speed when no force acts on them. Okay, now please understand these statements very carefully, because we are going to use whatever we have learned now, whatever I've explained to you, what you have studied in the 8th standard, to understand this much better. So what Galileo did, he said objects will move with constant speed. Constant means same. So something that was moving should move. Okay, constant. If it was moving with 10 meters per second, it will move with 10 meters per second. Constant speed. Okay. When no force acts on them, that means there is no force acting on it. That means the ball was moving with 10 meters per second. No one kicked that ball to increase the speed. Remember, right? Force can change the speed of an object. Here we are saying no one is applying any force on that object. The ball was moving with 10 meters per second. And Galileo said, if you don't apply any force on it, then it should keep on moving with that speed. No force acts on it, so it should move with a constant speed. With this in mind, he performed an experiment to see whether he has thought about it, right? So whether it is really true, not true, he did an experiment. Now, what was the experiment? Let's understand. He took two, what I can say, a race track kind of. Okay, so these Hot Wheels that you get the games, and then you have a complete rack. Okay, and then you keep the car, and then the car will move in a certain direction on the track, and then I hope you are getting it. So he took something like that, but straight. Okay, so there's no curves at all. He took two tracks like that, joined together, and at an angle. So you can say in the form of a V. And then what he did, instead of a car, he dropped maybe a table tennis ball. Now, what was the statement saying? If no force is acting on the object, it will move with a constant speed. So here, what is the object? The ball. Okay, so he just left that ball over there, and the ball came rolling down, and then finally it went down a little bit on top, and then it came down again. So he was trying to understand, okay, if we are saying that no force is acting on it, then it should go on top, but it did not go. Maybe because the steep of that V is too much. So he reduced that steepness of that slope a little bit more, and then he dropped the ball. So technically, if you're looking at it right now, and what can you understand? Where would actually the ball move? It should reach the top, right? It's sliding. No one is acting. No force is acting on it. The laws were telling us, the rules were telling us that force can change the shape, force can change the direction, force can change the speed. Now here, no force is applied, so it should move. That is what even Galileo taught. And then he did the experiment. So he left the ball went up, ball went little bit more, okay, little bit more at a distance, and then it stopped again, then came back down. Okay. So maybe still he thought the angle is still more higher. So let me reduce it and keep it flat on the ground. And he did something like this. Now technically what should happen? No force is acting. There is no angle that it is higher, or there is no inclination, there is no slope. So the ball should move, right? And then he left the ball to realize that after a while the ball actually stopped, even though the track was completely flat. Now, why do you think this thing happened? Why was he able to observe such a, the result of that experiment was something like this? What was the rule saying? It was saying that if there is no force applied and something is moving at a constant speed, it should keep on moving. There's no force, right? No one is stopping it, nothing to obstruct it, but still it stopped. Based on this experiment, okay, he came to know that it is impossible to have zero unbalanced force. Okay, what is the meaning of unbalanced force? When forces are more on one side and less on the other side, equal forces, this is unbalanced force. Okay, balanced and unbalanced. So here it is impossible to have zero unbalanced force. That means you can't have force only on one side and the other side is completely zero. It's not possible like that. Okay, if it was possible, then only this ball which was sliding would roll and move continuously. So what kind of a force is acting over there? You must have learnt in the 8th standard that there is something called as frictional force. When two objects touch each other, there is always a frictional force. The more the smooth the surface, the lesser will be the frictional force. The rougher the surface, the more will be the frictional force. So what is that? Frictional force is nothing but the opposing force which is usually is seen in the opposite direction of the applied force. So in case, okay, for you to understand, this is one surface, this is another object. Okay, this is, I am trying to slide this object on the surface, right? Now, if I'm pushing this object in this direction, there is a force which is completely opposite, which is trying to stop this motion. Okay, so that is the frictional force. So, and because of that frictional force, the unbalanced force cannot be always, it's impossible to have a zero unbalanced force. So I hope you are able to understand this. That's the reason whenever you are playing maybe football and then you kick the ball, after a while the ball will stop. It won't go on and on and on because there is a frictional force between the ground and the ball itself. So frictional force will be there no matter where you perform this experiment. Okay, on whichever surface you might, you can reduce the frictional force, but you can't make it zero. Now, so I have there's a small boy who's trying to move this box. Okay, so now the boy is trying to push it and he's not able to move it. Okay, he's putting in full energy, pura josh. Okay, and he's not able to move it. So what is happening here? The force that the boy is applying. Okay, before that, to understand it better, when will an object not move? Or you remember that rope, three people were pulling on this side, three people were pulling on the other side. They were not, the rope was not moving when the forces were equal, right? So the force on the three teams which are in red and the one in blue were equal. That's the reason the rope was not moving, though forces were applied. Same, apply that logic over here, and you will be able to understand that the force that the boy is applying is exactly equal to the frictional force that is, trying to be applied in the opposite direction. So the boy is, trying to push, same way the frictional force also is pushing that object in the other direction, and since the forces are equal, the object is not moving. Clear? Okay. So frictional force is that force acting in the opposite direction of the applied force. I've already told this to you. Okay, based on all this information, okay, I hope you know who this is. Okay, Newton studied the Galileo's work and he proposed three laws of motion. We already always say that they are Newton's laws of motion, but whose work did he understand? Whose work did he study? He studied Galileo's work, okay? And based on his understanding, he proposed these three laws of motion. Let us understand what is the first one. All right, so here there is one cup, or you can say glass. On that we keep a cardboard. Okay, on that we keep one coin. Now, these objects are there. Is there any external force? No. So, what is our understanding? Where objects will move only when we apply external force, correct? Force can change the shape, force can change the direction, and force can change the speed of an object. So, here no forces are applied. No. The moment someone flicks that cardboard, the cardboard, now what is happening? The cardboard was there, someone applied force. So what will happen? It will change the direction, so it moves, okay? And the coin falls in the glass. You can try this experiment for yourself at home, but the coin falls in the glass. Why? Why did it fall? Okay, that's the question. Now, based on Newton's first law of motion, look at this. A ball was moving, and a boy, comes in front of it and hits that ball. So, the ball stopped moving. So, what is the first law telling us? Newton's first law states that an object will remain at rest, okay? And at rest, so the cardboard was kept. Cardboard is at rest. Glass also is at rest. Coin also is at rest, okay? And it will remain there. Or in uniform motion. So right now, let us not talk about this uniform motion part of it, but we will not talk about this. Okay, so we'll just overlook that it is there, and we'll just say Newton's first law states that an object will remain in the state of rest, okay, unless acted by an external force. So if today I keep one jug or a mug or a glass on this table and I don't touch it at all, tomorrow if I come and if I don't touch it, no one touches it, the glass or the mug will remain there only, right? It will not move. If 10 years down the line, if I come and no one has touched it, it will still remain there unless there is an external force. So here in this case, in this experiment, what is the external force? The external force was flicking the cardboard. So Because external force was applied on the cardboard moved. But no one applied any force on the coin. Coin was at rest, so it will remain at rest. That's the reason from that on the it was resting on the cardboard. The moment the cardboard moves, the coin falls straight the below surface, right? In that is in the glass. Because the force was applied only on the cardboard, not on the coin, not on the glass, only on the cardboard. So object will remain in the state of rest unless acted by an external force. So if you don't apply an external force, the object will remain there only. Now let us go to the next part, or in uniform motion. So here the ball was moving. There is an external force, right? It was moving in a straight line. There was an external force. The boy came running and he stopped the ball. So the what happened? The object would have been moving continuously in a straight line unless acted by an external force. So the external force in both these experiments are, first one is flicking that cardboard, second one the boy coming and stopping the ball. So the first law clearly states that an object will remain in the state of rest. It will remain there, or in uniform motion. If something was moving, it should keep moving unless an external force is acting on it. You can say external unbalanced force, external force acts on it. So that's the first law which Newton gave, okay? First law of motion. Now, I'm sure many of you all will just by heart the law and will not understand anything. Please don't do that. The reason I'm explaining it so slowly for you to know what exactly is the meaning of that law. Don't just by heart it. I've seen students learning it like this. Newton's first law states that an object will remain in a state of rest or in uniform motion unless acted by an external force. कितना गिल रहे law? Don't do that. Okay, learn what exactly it is trying. Understand each and every meaning of the word, and you will know the law properly. So it is saying that any object will remain there only if it is at rest, or if it was moving it will keep moving unless an external force acts on that object. Okay, something the external force has to do to that. Okay, either it has to push it, or it has to change its shape, or it has to, if it is moving, then someone has to kick it and change the direction. Something has to be done by an external force, then only the change will happen, otherwise nothing will happen. So object will remain in the state of rest or in uniform motion unless an external force acts on it. Okay, now the tendency of an object to remain in the state of rest, okay, or in motion is called as inertia. So it's a new word, remember this, okay. That tendency, okay, that object says I will remain here, okay. So that tendency, it is capable of staying over there. Okay, sometimes they say this boy has the tendency, or if no one is watching, he'll do mischief. So there is tendency, he has that, you can say he has that potential to do something, but he might not do. Okay, so here that there is tendency of an object to remain there, okay, to remain in the state of rest, and that is called as inertia. I hope you have understood the first law of motion, and if you did, then please don't forget to hit that like button, share this video with your friends, subscribe to the channel, and till then, take care and bye bye. God